Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leave Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Right, the 2014 question from paper 1 on the Leave Cert syllabus first of all asked you for differentiation from first principles and then gave you a quotient rule. So let's have a look at differentiation from first principles. A normal colour. So differentiation from first principles, you have to remember the formula. It's not written anywhere. Okay, and it's basically the foundation of all of the rules of calculus. Okay, often called step 1, step 2, step 3, step 4, step 5. Okay, so if you're not sure what I mean by any of that, run down through some of the videos I have on first principles. So f of x is equal to 2x squared minus 3x minus 6. F of x plus h is 2 times x plus h squared minus 3 times x plus h minus 6, which is equal to x squared plus 2xh plus h squared minus 3x minus 3h minus 6. Okay, so like I said, if this is too fast, you get very fast at doing this when you have practiced a few of the first principles. Okay, so the third rule then says subtract them. So that is literally everything I've written here minus this one. Minus 2x squared minus 3x minus 6. Okay, always say be careful. I always put these into square brackets because it's minus everything that's in f of x. Okay, so all of f of x will change sign. And what you found is, if you've done it right, is everything in f of x should cancel with something backstream. All of your f of x terms cancels, okay? And if you've done your signs right, that's exactly what will happen. And what you'll find then is what you're left with, everything with what you've left with has a h term in it, okay? Which is good because the next time we do it, we divide by h. Okay, so we end up with no h fractions because that h, now you have to cancel it with the h in each term. So that's the first term, that's h by h and h, okay? So if there's 1 or 10 terms here on the top, each of the terms has to be divided by h. Okay, so that we're left with 4x plus 2h minus 3. Okay, and the last bit is the limit. And that's where h approaches 0. In fact, gets so close to it that we assume the value 0. So I get 4x minus 3. Okay, I'm looking up here to my original function. If I was to do that by rule, I would get 2 2s are 4x minus 3. It's a match. I know my differentiation from first principles is right and I didn't make any silly mistakes in it. Okay, so that's the first part. Can be worth a nice few chunky marks in the in your exam if you're lucky enough to get one. And I say lucky enough because you would be delighted to get one of them in your Leave Cert, believe it or not. Okay, I'm just going to move this onto another page if it'll let me. It doesn't want to do that. Okay. So it's not moving for me. That's fine. We'll use the same page because it's all recorded anyway, so it doesn't really matter. F of x is equal to 2x over x plus 2. Okay, and x is not equal to -2, okay? That stuff can get a little bit intimidating, but it's kind of important because sometimes they ask you for what values does this function not hold, or example. So on the bottom, you can never have a number that you can't divide by 0. So that's why x cannot assume the value of -2 here, otherwise you'd be dividing by 0. So when they write that, they're just obeying the rules of maths, okay? It doesn't actually interfere with your question in any way. So this is a u over a v. So it's a quotient. So if I go to my log tables and I go to the calculus page, you can see our quotient rule is v times du dx minus u times dv dx all over v squared, okay? And it's a quotient because it's a u divided by v. It's one function divided by the other. Okay, so let's figure it out, all our different parts. U is equal to 2x, v is the one on the bottom, x plus 2, du dx is equal to 2, dv dx is equal to 1. What am I doing when I do all those 4 parts? Well, I'm just checking out which one comes first. So v times du dx minus u times dv dx all over v squared. So what I'm doing when I do these 4 pieces is I'm figuring out the 4 pieces of the rule. There's 2, there's u, there's dv dx. So u, du dx, v, dv dx. Okay, so you're figuring out all 4 pieces so that you can sub them into the quotient rule. So dy dx then is equal to v times, so x plus 2 times du dx minus u times dv dx all over v squared x plus 2 squared. Okay, so let's multiply that out. I'm getting 2x plus 2 minus 2x over x plus 2 squared. Okay, 2x and 2x cancel. Sorry, made a mistake there. 2 by 2 is not 2, it's 4. Minus the 2x all over x plus 2 squared. Cancel, cancel, so I get 4 over x plus 2 squared, or 4 over x squared plus 4x plus 4, whichever way you want to write it. I would probably leave it like that. Okay, now what did the question ask? Find the coordinates of the points at which the slope of the tangent to the curve is a quarter. Okay, what does that mean? Okay, so find the coordinates of the point at which the slope of the tangent to the curve is a quarter. Okay, so basically what is it saying? It's asking at what points is slope, which is dy dx on a curve, equal to a quarter. Okay, so basically it's asking you then in maths language, when is 4 times x plus 2 squared equal to a quarter? Okay, so when I solve this, it will give me the x values for which the slope is a quarter. The question asks for the coordinates, so then you go back and you find the y value. Okay, so let's find this x value first. So I'm going to cross multiply. You can always do that when the equal sits in the middle, so that I get 4 times 4 being equal to 1 times x plus 2 squared. So I have 16 being equal to x squared plus 4x plus 4. I'm going to bring the 16 over because I see a quadratic forming. So I have x squared plus 4x. It'll be a minus 12 equal to 0. Okay, let's solve that. I get x and x. 6 and 2. I need plus 4x. So x is equal to minus 6, x is equal to 2. Okay, so now I'm down here and I see 2x values for where the slope is a quarter. So I'm back up to my question, and yes, indeed, it says coordinates. Okay, so I'm now not surprised that there's 2 values. If that had said coordinate, then I would have had to have a further think and go, is one of these values do I discard one of these values here? Okay, but no, it's at coordinates. Okay, so now I need to find out the y values. Okay, so we have x is equal to -6 and x is equal to 2 from there. Okay. So to find the y values, you do not go back to dy dx, because that slope, that is not y, that is y differentiated with respect to x. So when you ever need to find a y, you go back to the original f of x function. So what is, well, we know f of x is equal to 2x over x plus 2 when x is equal to -6. So our first answer here, y equals 2 times -6 over -6 plus 2, which is -12 over -4. So I'm getting -12 over -4, 3. Okay, so that is the point -6, 3. Okay, now, so that's 1 point. When x is equal to 2, y is equal to 2 times 2 over 2 plus 2, which is 4 over 2, which is 1. So that is the point 2, 1. So regardless of whatever that curve is, you have figured out that at the points -6, 3, 2, 1, the slope is a quarter. Okay, so regardless of whatever that curve is, there is 2 points on it. And I'm just randomly drawing a curve. Okay, you have figured out that the slope is a quarter there at -6, 3, and over here at 2, 1. Okay, I just got a bit lucky that my y values matched correctly. Okay, but right at those values, and remember I just made up that curve, the slope is a quarter. And that's that question done. If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice. In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.